strange looking R is a symbol that we used to use for representing all real numbers. So this would be the real axis. The I stands for the imaginary axis. And so the reality is here we're graphing the A's on this one and the B's on this one. And so the point out here is represented by the ordered pair AB. Remember that A is the real part of the complex number and the B is the imaginary part. The absolute value of a complex number is the distance from zero. And so the rule we use is if Z is equal to A plus BI, then the absolute value of Z is the square root of A squared plus B squared. And anybody tell me where this comes from? Okay. More simpler than that. No. Even long before you understood any of that kind of stuff, you knew this. What does the absolute value represent again? How far it is from zero. Right? So if we have this point, AB, then we're talking about this distance, right? So where do you think this comes from now, the square root of A squared plus B squared? Pythagorean theorem. We're just looking at this triangle. If I could draw a right triangle. We'd be looking at that. Okay? And so this is A and this is B. And so A squared plus B squared equals Z squared, right? We said that's the distance. So the absolute value of Z is equal to, or the absolute value of Z is going to equal the square root of A squared plus B squared. Okay? He was going to say that, but didn't want to, huh? Okay, so that's all we're doing here. So the polar coordinates of a complex number are theta. R represents the absolute value, or also called the modulus of the complex number. And the angle theta is called the amplitude or the argument of the complex number. Remember, theta is not unique, so we can replace it with 2 pi k plus theta. So in other words, if this was, if this was 30 degrees, then this would be 30 plus 2 pi k, meaning we can go around the unit circle as many times as we want, k times, and multiply by 2 pi each time, and we'll get another one. So if k was 1, we just went around once, it'd be 360, since I said 30 degrees, it'd be 360 plus 30, or 390. And then in radians, it would be pi over 6 plus 2 pi. Okay, so that's 13 pi over 6. All right? K again has to be an integer. And then if we put this in polar form, A represents R cosine theta, B represents R sine theta. That kind of looks familiar, right? Before it was X and Y, right? And so then if we plug that in to write it in polar form, A plus BI becomes R cosine theta plus R sine theta I. And if we factor an R out, we get R times the quantity cosine theta plus I sine theta. Anybody have an idea why they write it this way and not sine theta I?
Because it might be confused.
sine, and it's not. It's sine theta times I. Okay? So that we avoid that confusion, a lot of times I is written first. Even though it's supposed to be the form A plus BI, we write the I first because we don't want to confuse it with the other part of the problem. Okay? Good job, man. All right, this is known as polar form or trigonometric form of a complex number A plus BI. Do you have any questions on just the language of this? The application of it, we're going to begin right now. I've got a whole bunch of examples picked, worked out here. If at some point you feel, hey, we got this, then I'm not opposed to stopping. Okay? So the first one I said was 18. Can someone read the directions for me for number 18?
Solve each equation for x and y where x and y are real numbers.
Solve each equation for x and y where x and y are real numbers. Okay? So I'm going to pause this while I write. So this is number 18. We're solving for x and y as real numbers. And so simple factoring, what do we have common in both of those terms? I. So this is 4x plus y minus 5I. Right? Since I'm using parentheses, Trent, it's all right to put the I at the end. Feel free to copy this down. And now let's look at the rest of this now. I have a couple I's here also, don't I? And so if I factor that, I get 2x minus y plus x plus 7I. Okay? What's that? Let me pause just for a second. I'll make sure. So, what we want to do now is we want to, these two statements are equal to each other, right? And this is in A plus BI form, and this is in A plus BI form. It might look more like it if I did this. Okay? And if these two complex numbers are equal to each other, then we can write two statements now, because that means if they're equal, this A has to equal this A. Right? And this B has to equal this B. And so my first statement's going to be, what's this A? 4x is equal to 2x minus y. And in my second statement, I'm going to say y minus 5 is equal to x plus 7. You agree with that? So, a little simplifying here, 2x is equal to negative y. Okay, I think I'm going to change that. Yeah. And so, I'm going to switch my negative over to the other side, get y is equal to 2x. No, I'm sorry, thank you. Negative 2x, I did know that. And then over here on the other side, we want to set that equal to y also. And so we're going to add 5 to both sides. And so y is going to equal x plus 12. Now go back to your basic rules of algebra. In algebra 1, when you solve the system, what do we do now? Yeah, we're going to substitute this negative 2x in for that y and get negative 2x equals x plus 12. So if I move my x over, I have negative 3x's equals 12. So x is going to equal negative if I go to this one here, I'm gonna say negative 2 times negative 4 is equal to y, so y is equal to 8.
You'll have problems where they won't equal the same thing, correct?
What's that?
You'll have problems where they won't necessarily equal the same thing as an extra answer.
I'm not sure I'm understanding what you're asking me.
Like to the point where
What won't equal the same thing?
like putting in the equation won't get you the same answer both ways.
Oh,
Even though
you're saying if I want to try to check this.
even though negative 4 plus 12 is still 8. I'm asking if that's necessarily always the case.
Now from here down, it's going to be just like algebra. These answers will work in both of these equations. Okay? They will. The confusing part would be to try to take that all the way back up here. Let's see. If we put negative 4 in, we get negative 8. And y was 8. Negative 8 plus 8 is 0.
Well, it's not the
Oh, right. I'm sorry. That's an I. So we get negative. Oh, I didn't even multiply correctly. Negative 16. Sorry. And then this was 8 minus 5 is so plus 3i. If I go over here, I get 2 times negative 4 is negative 8. Minus 8 more is minus 16. And x was negative 4.
Yeah.
So negative 4 plus 3, or plus 7i is plus 3i. So even if I go all the way back to the beginning, they need to check. Okay? Good question. All right, let me pause for a moment. So in number 24, they ask us to find the absolute value and to graph this on the complex plane. So the graph looks like this. Square root of 2, what is that about?
1.4.
1.4? And so that means AB is 4 and around 1.4. And so when I graph that, I'm going to go over 4 and up almost to 1.5. And so that's my point P. Okay? So there I graphed it. Now the absolute value, remember this is the real number part, or the A. This is the imaginary axis, or the B. Yeah, the B, sorry. And so the absolute value, we'll call it Z, because that's the way our model was in our notes. It's going to be the square root of, yeah, A squared plus B squared. Now we should not use an approximate value here. We know that number is square root 2. But when we're graphing, we have to decide where to put that dot, so we have to round it off and get kind of close, because we can't graph the exact location. So this is the square root of 16 plus 2 is 18. Now, do I leave it like that?
Simplest radical.
There you go. Simplest radical form is going to be, yeah. This 18 is 9 times 2. So square root of 9 is 3 times square root of 2. So that's the absolute value. Questions on that one? Okay, number 28, they give us 6 minus 8i, and they ask us to express each complex number in polar form, right?
So you just plug it into the thing.
Yeah, well, what I do, first of all, is I recognize what quadrant is this.
Two. No, 4.
Yeah, this is A, we think of that, where the x or the a term is positive and the y or the b term is negative, we're talking about this quadrant right here, so quadrant 4. Why is that going to be valuable to us?
To know if you have to add to make it not negative.
Well, in polar form, I need to know the what? Don't they ask us to find r and theta? So I need to find theta, right? And so to find theta, I need to know which quadrant I'm in. Because I might work it out and get 30 degrees, or say pi over 4 if I go radians. Okay? But if I need to be in quadrant 4, then I need to move that to quadrant 4. Did they tell us what theta should be between? Okay, so they didn't say it should be between 0 and 2 pi or anything like that. So they didn't tell us it had to be a positive number, so we could just go negative. We could go this way to get to it, the closest one to it. Okay? All right. Let's go ahead and start this then. From the notes, we said A is equal to what?
R cosine.
R cosine. And B is equal to R sine theta. Right? And R, how do we find R? Yeah. Square root of it, you meant, right? Okay. And so A is 6,
Yeah.
and R is going to be square root will work up here. Square root of 6 squared plus 8 squared. It's really a negative 8, but I'm squaring it, so what's going to happen?
It's gonna be positive.
I'm going to end up with a positive number anyway, right?
So
So 36 and 64 is 100, which is 10. So R is equal to 10. Okay, so we're going to say 10 cosine theta, and B is negative 8, and that's going to equal 10 sine theta. So cosine theta is going to equal 6 tenths, right? We divide both sides by 10. I'm going to reduce that to 3/5. And sine theta is going to equal negative divide by 10, 4/5. Right? And we can solve for we can solve either way. Okay? Or we could say tangent is negative 4 over 3. Okay? Actually, they just use this. Oh, I'm sorry. I made this a little harder than I need. I could have gone right to that. I'm just in the habit of doing the sine and cosine, not creating the tangent function. But the reality is, we didn't need to do this because, or even this in fact, because we could go straight to tan is equal to B over A. And so theta is going to equal the inverse tan of B over A. And so that becomes negative 8/6. Negative 53.1. I, for some reason, turned that into 306.9. Are you sure in the directions it doesn't say? Okay.
It gives you a negative when you do the sine and the tangent. These tangents negative a quarter of 4.
Yeah, I mean, any of those three methods, that's why I just always are in the habit of using sine and cosine. And then recognizing what quadrant I'm in. And then as I I looked back at my notes after I wrote that down, I realized, yeah, they did tell us this a long time ago. The tangent's always equal to y over x. Well, we have to know what theta is to put it in our model. If we go back to this is our model. And we need to know r and theta to put it into that model. Okay? And what I started to do in this problem was this step here. I applied these just like we did to get to this formula. I applied that. That's what I started to apply. And then I realized that we do have that formula, so we don't have to do all that work. And so z is equal to r, I'm going to write it down, cosine theta plus I sine theta, right? And so we found r to be 10. And so this would be, the way we did it, we would get negative 53.1 plus I sine of a negative 53.1. This is our model. Okay, that's the way we did it. I'm not sure why I did it the other way. I'll look at that again closer in a minute. But I wrote it this way in my notes. I'm thinking this is where the answer was. 306.9 plus I sine 306.9. So what I'll do is I'll go back and look at the rule again just to make sure it doesn't say in the rule that theta should always be positive.
Would you give us limits on the test?
Well, again, if there's no rule that I overlooked in the notes, and if the directions don't say to put your angle in a certain limit, then I'm smart enough to know that this angle and this angle are the same, and I'm not going to deduct points on that. Okay? But I want to reserve that total answer to that until I go back and look at a rule where we derived this formula in the first place. I want to make sure there's not a rule within that formula or some wording that says that the angle should always be positive. Okay? Or between 0 and 0 and 25 or 360. Okay? I didn't see it. I didn't have it in my notes, so I don't think it is. But I'm just wondering because I had it in my notes this way, not the other way. Okay? Do we have any questions on this one? Okay? So in number 36, again, just to make sure that those at home can know what the directions were, they ask us to graph this polar form, right? Yeah, and it's in polar form. They want us to graph this and then write it in rectangular form also. Okay? So the first thing that I would recognize, and I'm going to write it in green, we're looking at this model, this polar form that looks like this. And so when I'm looking at that in this problem here, what's missing? R. So what's that tell me? What's that? That's a find R. It's not a where's Waldo though. It's actually there. I guess Waldo's actually there too, so maybe it is a where's Waldo. But it's not a trick here. What is R in this case? 1. Because that's the only number that when I wrote it in this form, I wouldn't actually have to write, correct? Because any other number still have to be there, wouldn't it? So in this case, it's got to be a 1. So when I go to graph this, this, and then I'd have a bunch of lines. Through here. Sorry, it's taking longer than I wanted to. So it looks something like that anyway. And negative pi over 6 is this one, right? Do you agree?
Yeah.
Okay. And on my graph paper, I labeled this as 1, 2. Okay. So I'm saying every ring is a half a unit, right? And so I go to graph this then. R is 1. I get 1 and negative pi over 6. And so that's going to be right there, correct? See? See, senor. Work on our Spanish and math class. See, we can do other things in our curriculum. You didn't do it well. Okay. Now, the next question is, what is this value? Remember, A is equal to R cosine theta. And B is equal to R sine theta. And so what's 1 times cosine negative pi over 6?
Negative root 2 over 6.
Yeah, that's right. And so A is equal to, I'll go ahead and write this out, 1 times cosine negative pi over 6. So that's negative square root 3 over 2. And B then is going to equal 1 times sine negative pi over 6.
Positive.
Oh, wait a second.
Yeah, are you sure that's not positive?
Yes, it is. Cosine's positive. I don't know if you said that or if my head said that, but it should be positive, not negative. Okay? So now on this one, the sine of negative pi over 6 is a negative 1/2. And so times 1 is negative 1/2. And so we want it in this form, rectangular form. So what do we get? Square root 3 over 2 minus 1/2 I. Okay? Or occasionally the book might actually adhere to the A plus BI and say,
Plus negative.
yeah, they might say that. Okay? All right? So, what I have for homework is I think 37. And you will definitely have time on Monday. In fact, I might not give anything else on Monday. If I do, it'll just be more notes. Okay? If we look at the calendar for a moment, let me pause this while I get it. If we're all working next week, then I will entertain the idea of a group and individual test again. If we're wasting time, we're not taking notes, we're not working when I give you time to work, and I'm talking about everybody. So, you know, be active in your group to get everybody working. And then, at least those people will not take a group test. So, make sure you understand that. If you're not working next week, I'm going to be very diligent to watch your effort, watch what you're doing. If there's way more conversation and chatting than there is math, and we're not done with our work, I I expect your assignments all be done by the 21st, no later. Okay? You should be caught up by now. If you're not caught up by now, then you've not been working the last 3 days. Because you were given all of 2 days to just get caught up. So anyway, I will take that in consideration. I'll take what you've been working on, how I've seen you working in class, and I will tell you on, no, I won't be here Friday, so it'll have to be Tuesday when we come back. I'll say to you that you don't have anything, you don't have enough done, you're on your own, you're not gonna take a group test. Okay? So, I wanna give you a group and an individual test. And then exam review will start the 28th, probably the day of the group test. The individual test. I kinda wanna do the group test first, then the individual test. I think to me it makes more sense, you have one more chance to learn things you didn't know. And I guarantee it'll be like last one, if there's multiple choice questions on the individual part and you only have the answer, you will lose all but 1 point. So if it's a 4-point question, you'll get 3 points taken off if you don't have the work to back up your answer. In other words, and I also want to warn you, that there's probably not going to be identical questions. The question will be identical, but the numbers will be different. I will change them this time. I did it last time, but I will this time. Last time we had some time